Let A be the set of all integers. Let R be a relation defined on A such that A is related to B if and only if 2 times the first element plus 5 times the second element is divisible by 7. Okay, before jumping into the solution, let us try to understand the relation first with the help of some examples. Is 1 related to 8? Yes, because 2 times the first element plus 5 times the second element is 42. We know that 42 is divisible by 7. Now, is 4 related to 4? Because 2 times 4 plus 5 times 4 is 28, which is divisible by 7. Is minus 4 related to 3? Yes, because 2 times minus 4 plus 5 times 3 is 7, which is, yes, divisible by 7. Is 2 related to 4? No. Since 2 times 2 plus 5 times 4 is 24, which is not divisible by 7. In this case, A is related to B if and only if 2 times the first element plus 5 times the second element is 7 times some k. Okay, now let us check the property required for equivalence relation. So the very first is reflexive. So for reflexivity, we have to check whether A is related to itself for all A in Z. Now, as 2 times the first element plus 5 times the second element is 7A, which is obviously divisible by 7, and as this happens for any A in Z, so A is related to A for all A in Z. The second property is of symmetricity. That is, we need to check whether B is related to A whenever A is related to B. So first, we will assume that A is related to B, and our aim would be to show that B is also related to A. Now, as A is related to B, so 2 times the first element plus 5 times the second element will be some 7k for some k in Z. Now, if somehow we prove that 2 times B plus 5 times A is a multiple of 7, then we are done. It will prove that B is related to A. But observe that 2 times B plus 5 times A can be written in this way, which can be simplified further in this way. And we can observe that it is, yes, a multiple of 7. This proves that B is related to A, which implies R is symmetric. Now, third and the last property is of transitivity. That is to check whether A is related to C whenever A is related to B and B is related to C. So we are going to start with assuming that A is related to B and B is related to C, and our aim would be to show that A is related to C. Now, as A is related to B and B is related to C, this implies that 2A plus 5B is some multiple of 7, that is 7 times some k1, and as B is related to C, this implies 2B plus 5C is some 7 times k2. If somehow we prove that 2A plus 5C is a multiple of 7, then we are done. But observe that 2A plus 5C can be written in this way. We have just added 7B and subtracted 7B, which further can be written in this way. But the first two element is 7k1. Third and fourth element is 7k2. And the last element is minus 7b. So altogether it is 7 times some k dash. This proves that 2A plus 5C is a multiple of 7, which proves that A is related to C. Hence R is transitive. Therefore, by A, B and C, we can conclude that R is an equivalence relation.